Alright, welcome to part 2 of Unit 8 work, dealing with quadrilaterals and polygons. We're actually continuing right where we left off with trapezoids and mid-segments are the pieces that we're really talking about here. So when I look at these pieces here, I have a top, I got a bottom, and I got a middle. And I know that the middle is the average of the top and bottom. So the average of two things would be the top plus the bottom. Then I add them up, I'm going to divide by 2, and that's going to equal my middle. So I'll start with that template, then plug in the pieces I have. The top is 22. The bottom is 6x plus 4. The middle is going to be 19. So I got to average this side to get to the 19. Well, I got a fraction here. I'm going to get rid of this 2 first. So let's start with that. 19 times 2 on the right side is going to give me 38. And if I simplify this left side, 22 and 4 will add up to make 26. So you got 22 and 4. That makes 26. And we got 6x added onto that. Now I just got to solve for x. So I'm going to subtract 26, subtract 26. And that gives me 6x equals 12. When I divide by 6 on both sides, I should get x equals 2. And all it did was ask me to solve for 2, or solve for x. So I got x equals 2. I don't have to plug it back into anything. Let's take a look at the next one. This one's going to be similar. They're asking us to find BE. So first we got to solve for x, then we have to plug it back into this little piece right here. So let's look at what we have. We got a top, we got a bottom, and we got a middle. And we know that the top plus the bottom divided by 2 equals the middle. That's our average of the two bases is going to equal the middle. So let's put those together. Negative 26 plus 5x, that's our top, plus the bottom is 2x minus 2. We're going to divide all that by 2, and that's going to equal our middle, which is 2x plus 4. So I got to multiply both sides by 2, got to get rid of this denominator. Let's start with that. That means I'm going to have 4x plus 8 on the right. On the left side, I can add the 5 and 2x, so that's going to give me 7x. I can add the negative 2 and negative 26, that's going to give me negative 28. These two pieces are equal. So I'm going to subtract 4x from both sides, subtract 4x. I'm going to add 28, add 28. And then from the algebra, we should get 3x is equal to 36. From here, we're going to divide by 3 and find out that x equals 12. Now that's very helpful, but that's not the finished piece. We still have to plug it back in to the x for the piece that they're asking us to find, which is BE. So that's going to be negative 26 plus 5 times 12. 5 times 12 is 60, so negative 26 plus 60 is going to simplify to 34. So that means this top piece was 34. That's our final answer for that piece. Let's keep moving on here. Next to this one. Okay, so find the measure of the angle indicated for the trapezoid. Notice that not only is this a trapezoid, but it's got a couple of other markings here. It's got equal legs. And if it has equal legs, or congruent legs, I guess you could call it, then that means that it's going to be isosceles. And if it's isosceles, it's symmetrical in a lot of ways. In other words, angle Z and angle W are going to be equal, and so are X and Y. So if I look at this, this is actually a straightforward relationship. One side is 99 degrees, so is the other. It's 99 degrees because it's a trapezoid with equal legs, and equal legs means it's isosceles, which really means it's symmetrical. Symmetrical shapes mean that it's kind of balanced, the same on both. Get another one that's similar. Okay, so I know that pieces are similar. So this side's going to be 75, and this piece right here is also going to be negative 2x plus 105. But now for any trapezoid, when I'm talking about base angles, one from each of the bases, these two lines here are going to be parallel. QT and RS are parallel. And if those are parallel lines, then I'm going to have a supplementary relationship. Q and R Let's try and circle that again. Q and R are actually supplementary. So if those two pieces are supplementary, then that means that they add up to 120, or 180, pardon me. So that means that 75 plus, and then we got negative 2x plus 105 is equal to 180. So I got to simplify this a little bit. First of all, I got 75 and 105. That's going to give me 180. I got negative 2x plus 180 equals 180. Now, there's something that should kind of be clicking in your head here. How can I add something to 180 and it's still going to equal 180? So then this piece here must be 0. But if I simplify further, that becomes even more obvious. So I have negative 2x equals 0. Well, then when you divide by negative 2, you're still going to get x equals 0. That term right there had to be 0. So what does x equal? X equals 0. Booyah. Let's see what's next. 59, find the measure of angle V. So they're asking us this piece right there. We know again that this is a trapezoid, that it has equal legs, therefore it is isosceles, which means it is symmetrical, which means that angle S is congruent to angle V. So we can start, angle V. That means that we can set those two things equal to each other. 12x plus 1 equals 14x minus 13. Now if I balance this and start doing some of the algebra, I'm going to subtract 12x from both sides. I'm going to add 13 to both sides. That's going to give me 2x equals 14. Divide by 2, x equals 7. Okay, so that's good, but I got to do more than just that. I got to plug it back in to here. So I'm going to have 14 times 7 minus 13. Well, let's see, what is 14 times 7? 7 times 4 is 28. 7 times 1 plus 2 is going to be 9. So that's 98. And then I got to subtract 13. 98 minus 13 is going to give me 85. So this angle right here, this is 85 degrees. That wasn't too bad. And just so you know, the other one would have also been 85 degrees. That's kind of an interesting thing there, because we got that symmetry, both sides are equal. All right, this one's nearly identical. It's asking for angle V, but notice that the angle V is actually down here. It's not in the top piece. We know that these two pieces that I'm about to mark, that angle W and angle T, are congruent, but that's not the angle it's asking for. It's asking for angle V. Well, let's go ahead and set up the relationship and then see if we can work our way down to the angle V. We know that these two pieces, W and T, are going to be equal. So angle W is congruent to angle T. That means that 10x plus 20 is equal to 16x minus 16. So we got algebra to do. I'm going to add 16. I'm going to add 16, and then I'm going to subtract 10x, subtract 10x. That gives me 36 equals 6x. If I divide by 6 on both sides, that gives me 6 equals x. Okay, well that's good enough. Let's go ahead and see what these would be. If I plug in x for 6 here, that would be 10 times 6 plus 20. That's 60 plus 20. That equals 80. So that means that angle W is 80 degrees. So is angle T. That's 80 degrees. Well, that being said so far, what do I know then about angle W and V when I put those together? Well, these again are trapezoids. They are parallel lines, or parallel bases, I guess you could say, if you want to be more specific. And because these are parallel bases, we're going to have a supplementary relationship here. That's supplementary. So angle W, measure of angle W, plus measure of angle V is equal to 180. We know that W is 80, plus whatever this other one is 180. Well, let's simplify here a little bit. If we subtract 80 from both sides, we're going to get that that missing one is equal to 100 degrees. So this down here, this is 100 degrees, and so is this here as well, angle U. A little bit of interesting kind of relationships there. Even though it asked us for angle V, the same as the last one. When you look at this last one, it also asked us for angle V. But the relationships are different. You got to be really careful as to which one you're plugging into. All right, let's keep moving on. We got 63 here. Each figure is a trapezoid. We got symmetry. Another thing of symmetry in these isosceles trapezoids is that the diagonals are congruent. That's just another property. So if the diagonals are congruent, that means that DF and EG are equal to each other. So these two pieces are equal. 17 equals negative x plus 27. Let's do some moving around here. I'm going to add x to both sides. I'm going to subtract 17 from both sides. That's going to give me x equals 10. So I solved for x. That was it. That's all I had to do. But the thing that's key here is to recognize that diagonals are congruent inside a trapezoid. Let's look at another one. Find the length of the diagonal indicated for each trapezoid. So they're asking me to find Vx. Well, if I look at these two diagonals, I got xv, this one going from bottom to top, left to right, and then we got top to bottom, left to right here. We know that those are equal. So 3x and 6x minus 24 are going to be equal. They're congruent segments there. So I'm going to subtract 3x from both sides. I'm going to add 24 to both sides. And let's see what we come up with. We're going to have 24 on the left side and 3x on the right side. When we divide by 3, x is equal to 8. That's helpful, but it's not all of it. We need to take this, and now we got to plug it back in here to Vx. So Vx equals 3 times x, which equals 3 times 8, which is going to give us 24. That's our final answer. So this whole length is 24. And so is the other one. Because there's symmetry, it's a trapezoid, and it's isosceles because the legs are equal. Let's look at the next one. All right, now we're starting to get into area. The first thing you need to realize is that area of a parallelogram is equal to base times height. A triangle is really half of a parallelogram. So the area of a triangle is going to be half the base times the height. And how do we know that the base and the height are the base and the height? The base is perpendicular to the height. So that's all we got to do is find the two perpendicular lengths. Well, I got a length here. This is 3. And then this one's 3 as well. But those are perpendicular because they both make a right angle if they're extended. So that means that the area of this one is just base times height, which is really 3 times 3. This 6.4 has nothing to do with the area. It has nothing to do with it. So the area here is just 9 yards squared. Let's look at this next one. I got 3 numbers. One of them does not have anything to do with area. It's the 6. Why? I'm using the 4 and 9 because they're perpendicular. That's the key. And this is a triangle, so I'm going to do that the area equals 1/2 the base and height, which is 4 and 9. Half of 4 is really 2, so that's 2 times 9, and that simplifies to 18. And again, now we have units, it's feet squared. So area equals 18 feet squared. This next one's a little confusing. A lot of people think of the height as this length here, but it's not. How do I know it's not? Because it's not perpendicular to the base. I need it to be perpendicular to the base, which this 2.5 is. So I have this area is equal to 2.5 times 5.8, but we got to multiply that by 1/2 because it's a triangle. I'm going to pull out a calculator for this one. I'm going to have, let's look at our screen. We're going to do 2.5, not 25. Let's clear that. Let's clear all this actually. Let's start with a fresh screen. 2.5 times 5.8 divided by 2. Set that at 0.25, so the area equals 7.25. We keep on moving here. Okay, now we got to find the missing measurement. That means they're going to give us the end result. And we got to see how do we set this up so we can find that piece in the middle. All right, we got a triangle. One of these numbers actually doesn't matter. The 5.5 doesn't matter because I need the base and the height. The question mark is my base. And my height is right here, 5.3. So the area of a triangle equals half base times the height. Well, that's going to be half. We don't know what the base is, so we're going to leave that as a question mark. And the height is 5.3. And we know that the area is actually going to wind up being 14.3. All right, well, let's work our way through this. Let's first simplify half of 5.3. If I go to my calculator, that's going to give me 5.3 divided by 2, 2.65. So 2.65 times the question mark, times that height, is equal to 14.3. Well, to figure out the question mark, now I got to simplify this 2.65. So I'm going to simplify that on both sides, 2.65. So I'm going to have 14.3 divided by 2.65. Let's see what we get. 5 point, a whole bunch here. So 5.3, 5.4. So the height is equal to about 5.4. And I should actually say this is approximately, because it's not exactly equal, but it's pretty close. All right, this next one. Again, we got extra information that we don't need. This is a parallelogram, and the area of a parallelogram is just equal to base times height. Well, our height is right here. It's 4, and the base is this question mark. So this 5.2, that would be like a slant height. We don't need that. So we're going to have 4 times a question mark equals our area is going to be 46.8. So all I got to do is divide by 4 to simplify that right side, and I'll be left with the question mark, the base. Well, I could do this by hand, but I have a calculator here. Let's see what we'd get. 46.8 divided by 4 equals 11.7. There's your base. 11.7. Exactly. Sorry for that interruption. Just a quick announcement here at the school, but we're almost done. We're so close. We're at 75, so close to the end. Gone. All right, find the measure of one interior angle in each polygon. Okay, so what we're looking at then, this is a polygon here, and it's regular, which they don't say, but they do mean. It's regular, meaning that all these are the same. So I'm going to put a dot about here in the middle. And then what I'm going to do, so I'm going to split this up into a bunch of triangles. And I want to see how many triangles I can make. There's actually more than one way to do this, but you know what? Let's go ahead and do it the other way. I'm going to do it the other way. So I'm going to do the little spokey wheel thing for another problem. But let's show you something different here. Okay, so I'm going to make diagonals, and I can do a whole bunch of them. I got 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I got a lot of triangles there after I made all those subdivisions. Let's see what I got. I got 1, let's see, we got 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got 10 triangles. 10 triangles, if I were to add those up, each of them is going to be 180. That's like 10 times 180. So I got 10 times 180. That's a total of 1,800 degrees inside. That's my total. To find each, just one of them, it's going to be the total divided by the number of angles, which is the same as the number of sides. So let's count that. Let's count the number of sides. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that 11 and 12 weren't counted when we made the triangles. That's actually a pattern. There's always 2 less than the number of sides, the number of triangles that you're going to be able to put inside a polygon. So the total is 1,800, And we're going to divide that amongst 12 angles because there's 12 sides, 12 angles. So let's use our handy dandy calculator here. 1800 divided by 12 angles is going to be 150 degrees. That means that one angle right here, this angle, is 150 degrees. That's not too bad. So what did we do? We split it up into triangles, multiplied it by 180, and that's our total. Then to find each, we took the total divided by the number of angles, or the number of sides. And that's where we got our 150 degrees. Let's do another one. Now as I'm looking at 85, it's asking similar questions, but it's saying one exterior angle. An exterior angle is these ones here, the ones that kind of make this like a fan-looking shape. So to make that fan-looking shape is kind of interesting. So if I rotate here, then I rotate a little bit more, a little bit more, a little bit more, a little bit more, all the way around. I made one full rotation and I returned where I am. And one rotation is equal to 360 degrees. That means that the total exterior angles is equal to 360. And this is true for all polygons that are convex, of course, all regular polygons as well. Okay, so then if I'm finding one, I just got to figure out how many there were to start with. Well, it looks like I have 1, 2, 3, 4, 5, and 6. So I got 6 angles. So I'm going to start with my total divided by the number of angles. That's going to give me 360 divided by 6. That means that each one is 60. Awesome. So that means that this is 60 degrees, this is 60 degrees, and so on and so on and so on. So each one is 60 degrees. All right, we just got a few more problems here. The interior angle sum. That means total. Well, this is actually easier than what we were doing. Same thing where we make diagonals. But this time, we're just going to use the total. So I got 1, 2, 3, 4, 5, 6, 7 lines. So let's count our triangles then. That means that we're going to have 1, 2, 3, 4, 5, 6, 7, 8. We got 8 triangles. 8 triangles means that we're going to have 8 times 180, which is the same thing as 4 times 2. What we get? 8 times 180. We got a calculator, might as well use it. 1440. So the total equals 1440. Excellent, excellent, excellent. Find the area of each regular polygon. This is the last one for today. Hopefully you guys have been doing pretty well here. We're going to do 2 examples of and 99. So let's first look at 97. It's best if you kind of think about this split up into triangles. And in fact, these are special triangles. It's a hexagon and it into something very symmetrical. All these sides are going to be the same. And if all those sides are the same, that means that all these angles are 60 here. That's 60, 60, 60. So what I really need to do then is figure out the area of one triangle and then times that by 6, and that gives me my total. Well, let's figure out the area of one triangle then. If I can do one triangle, then I can do the whole shape. Let's start with this triangle here. We know that each side is 8, but I'm actually going to split this bottom piece into 2 equal halves. It's going to be 4 and 4. Now when I look at that and I have this is 60 degrees and this is 60 degrees, but then these top pieces is going to be split in half. It's 30 and 30. Now I have a special right triangle, and when I know that I have a special right triangle where the hypotenuse is 8 and that one leg is 4, that means this longer leg is 4 root 3. And that represents my height of the triangle that I'm trying to find here. So if I'm trying to find the area of this triangle here, the area is really equal to half the base times the height. Well, the base of the triangle, that's pretty easy. That's 8 all the way across. So we got 1/2 of 8, and then we're going to multiply that by the height, which is 4 root 3. So this will be 4 root 3 there. If I simplify this just a little bit more, half of 8 is 4, so 4 times 4 root 3. And that's going to give me 16 root 3. That's for one triangle. For 6 triangles, that equals 16 root 3 times 6. Well, 6 times 16 is going to be 96. So that gives me 96 root 3 equals my total area. And there we go. That's it. And actually, if you look at the last one, it's a lot like that first one, but here's the difference. It's just a triangle. Instead of doing 6 triangles, we're just doing 1, but we're going to do the same thing where we say that these 2 pieces are 10. We're going to split this piece in half. We'll have 5 and 5. That means that this height's going to be 5 root 3. And to find the area of this, we need to do area equals half base times the height. The base is 10 because it's all the way across from here to here. This is the base. The base equals 10. And the height, again, this time is that half that base times the square root of 3. So then I'm going to have half of 10, which is 5. Times 5 square root of 3, which gives me 25 square root of 3. So that area was actually pretty easy too, and a lot of it has to do with the special right triangle. The special triangle with the 30, 60, 90. You're going to have to remember that one. And the thing to remember about a 30, 60, 90, let's draw this a little bit cleaner here. For a 30, 60, 90 triangle, let's draw these lines really clean. Perfectly straight. Perfectly straight. And the last one. There we go. For this special right triangle, you need to remember that we kind of have this relationship where we got a short leg, double that short leg, and then that short leg times square root of 3. And since we're given this piece here, we got to split it in half and then multiply it by square root of 3 to get the height. Alright, so that's it. Happy stars, and see you in class. Let's ask questions in the morning so we can study and be ready for this test.